Alright, so what we're going to try to do here is go through all the questions on the final exam review guide, and hopefully this will help you to prepare for the exam. So number 1, we have to simplify 49 to the 3/2 power. Now the first thing I'll tell you about both number 1 and 2 is don't be afraid to use your calculator with these. For number 1 here, you can simply in your calculator do 49 to the 3/2. Keeping in mind we like to put our fractions in parentheses, and you will get the correct answer doing that. Another way you can do this is 49 and then break the fraction up. So instead of 49 to the 3/2, it's the 1/2 cubed. And 49 to the 1/2, well, that's just the square root of 49. Square root of 49 is 7, and 7 cubed is 343. So you'll get that 343 in either case. My advice, though, is since you have a calculator, use it. And with the same reasoning here, again, with number 2, you can apply the rules of exponents. The negative exponent means 1 over 256 to the positive 1/4. And the fourth root of 256 is just 4, so this is really 1 over 4, or 0.25. But again, using the same technique, you can probably use your graphing calculator to get the answer. Okay, number 3 gives us a little bit of a story problem type scenario, but the key thing is it gives us this formula for the volume of a sphere. And the volume of a sphere is 4.18879 times the radius of the sphere cubed. And the problem says, what if we had a sphere with this volume, 47 cubic inches, what should the radius be? Well, for the volume is this guy right here, the V. What I don't know is the R, so I'm going to set up an equation. My volume, 47, equals 4.18879 R cubed. And R is the unknown, and the whole point of this problem is really to solve an equation where you have to take, in this case, a cubed root. So I want to get the R by itself, so the first move I'm going to make is divide both sides by 4.18879 and 4.18879, and I'm going to have to enter that into my calculator. 47 divided by 4.18879, and I will end up with R cubed, because these cancel, equals 11.22. Now at this point I just need to cubed root both sides. So the cubed root of R cubed equals the cubed root of 11.22. And remember, on my calculator, the way I cubed root is I'm going to do 11.22 to the 1/3 power. And make sure you keep those fractions in parentheses. And R is going to be approximately 2.24 if we round. Okay. All right, moving along, a little bit more stuff with radicals. Problems 4 and 5 are going to be very, very similar to one another, and they ask us to simplify. So I've got 6 times the square root of 3 plus 8 times the square root of 3 minus 2 times the square root of 3. And while it might not look like it at first, what we're really going to do is combine like terms. Notice that these are all square roots of 3. So if I've got 6 square roots of 3 plus 8 square roots of 3, combined, I have 14 square roots of 3. Right? 6 plus 8 is 14. Now I still have to do my minus 2 square roots of 3, but same idea. If I have 14 of them minus 2 of them, I will end up with 12 square roots of 3. And number 5 is very similar. If I have 9 square root of 7 plus 2 square root of 7, I have 11 square roots of 7. And if I minus 3 more of those, I will end up with 11 minus 3 is 8 square roots of 7. Okay, number 6 asks for what is the cubed root of 32 in simplest form? Well, the fact is I can't take the cubed root of 34. Well, I can, but I'll get a decimal. So what I want to do is see if there are any perfect cubes in there that I can take. And what I'm going to find is that the cubed root of 32. Another way to write 32 is cubed root of 8 times cubed root of 4, because 8 times 4 is 32. So I'm breaking it up. Now, I picked, there's lots of stuff that multiplies to 32. I mean, I could do 16 times 2, 8 times 4. But the reason I picked 8 times 4 is that 8 is something I can take the cubed root of. See, the cubed root of 8 is just 2. So my final answer is 2 cubed root of 4. So I looked for a perfect cube that I could take out of 32, and that's how I got my final answer. All right, number 7 shifts gears a little bit. It tells us that we have this function g of x is equal to negative 3x plus 2, or 3x squared. And remember that when we define a function, we have input and output. So we're going to input an x and then get some output, g of x. And this asks for g of negative 2. Well, to evaluate g of negative 2, I'm going to start on the inside and look just at g of negative 2. Well, the function g says take negative 3 times the input squared. Well, in this case, the input is negative 2. So 3 times negative 2 squared, and I will find out that that is, let's see, negative 2 squared is 4. 4 times negative 3 is negative 12. So g of negative 2 ends up being negative 12. So what I'm really trying to find is g of negative 12. So to find g of negative 12, I'm going to do the exact same thing. I'm going to go down, I'm out of room here on the right side, so I'm going to move down below. And let's evaluate g of negative 12. Well, I'm going to input the negative 12 to the function. And negative 12 squared is 144. And I'm going to have to use my calculator for this. Negative 3 times 144 is negative 432. So g of negative 2 is negative 432. Right, so this is page 2 now of the review guide. First question asks for the inverse of the given function. And remember that functions take an input and map it to an output. Well, the inverse does the reverse. So if a function maps input to output, the inverse of the function maps output to input. And the procedure for finding the inverse is pretty simple. Now, I know that sometimes we get a little messed up with the whole f of x notation, so we can replace that with y. We can think of it as y equals 3x plus 2/7. And the first thing we're going to do is we're going to switch x and y. So instead of y equals, we're going to say x equals 3y plus 2/7. And now the second step is solve for y. In other words, we want to get y all by itself. So again, we've got x equals 3y plus 2/7. And to get y by itself, I am going to minus 2/7 from both sides, minus 2/7. And so right now, I will have x minus 2/7 equals 3y. And then at this point, y is almost by itself. I just need to divide by 3 and divide by 3. So I'm going to divide each of these things by 3. And when I divide x by 3, so let me back up here. So once I do that, I'll have y equals, and when I divide the x by 3, well, that's just x over 3, or 1/3 x. And then when I go to do this part of it, you can use your calculator for that if you want to. A decimal answer would be okay, but I should end up with minus 6, let's see, divided by 3, And I'll end up with 2 over 21. Kind of a nasty fraction. Again, I might advise that you use your calculator on that. That's not a very pleasant one from a numerical standpoint. But the key thing is that I flip-flop the x and y, and then I solve to get y all by itself. That's how I'm going to find the inverse. All right, number 10, again, a bit of a story problem here. The key thing is this equation right here. And it doesn't look like it, but that's a square root symbol, square root of p. And this represents, let's see, a gas escaping a storage tank. So maybe not the most real-life thing unless you have a very specific job. The input to this function is the pressure in the tank. So P is the pressure, and E is the amount of gas that's escaping. I guess E for escape. And they say, what's the pressure when 450 cubic meters per minute are escaping? So what they're doing is they're giving me the E value and asking for the P. So it's really all about substituting and solving. So I'll set up an equation. So 450 equals 150 times the square root of p. The idea is what is p. So I'm solving an equation. The whole point here is really to solve an equation that has a square root. So not rocket science. Going to divide both sides by 150 because of course we want that p by itself. And 450 divided by 150 is 3. So 3 equals the square root of p. Of course we're going to, at this point, square both sides to get rid of the square root, and p equals 9. Okay. A little bit more with solving with square roots here and other roots as well. In number 11, you will notice that we have a square root equaling x. So the key thing here is going to be to get rid of that square root. Now the square root's already by itself. So I'm going to go and square both sides because square and square root cancels. When I do that, I will end up with x plus 56, see the square root just goes away, equals x squared. Now the tricky part here at this point is that I'll notice that I have a quadratic. So I've got an x squared, and that means I may have to do a little bit of factoring to get this solved. So my next move is going to be to put it in standard form. And by that I mean I want it equal to 0. So I'm going to have to end up subtracting x and subtracting 56 from both sides. So that x squared minus x minus 56 equals 0. So again, I squared both sides, and now I'm getting it all equal to 0 because that's going to be the best strategy for solving a quadratic, and a quadratic being something that has a square in it. So now I'm going to play the factor game. This will factor into x minus 8, x plus 7. And so my solutions will end up being 8 and negative 7, those being the two things that will make it 0. If I put an 8 in here, it'll work out and I'll get 0. If I put a negative 7 in here, it will end up working out and I will get 0. Okay. Next one, the square root, or in this case the cubed root, is not by itself. So my first move is going to be to minus 4, so that the cubed root of 3x plus 4 equals 4. Now I am going to cube both sides. So the cubed and cubed root will just cancel. So 3x plus 4 equals 4 to the third power, which is 64. And now it's a pretty easy solve. No factoring here. I just have to minus 4 from both sides so that 3x equals 60. And you can divide by 3 and x will be 20. Alright, last problem for this page. Graph the function f of x equals 2 to the x. And you can probably just use your y equals menu on your calculator, but if you were doing it by hand, I would do some input and some output. If you put a 0 in, 2 to the 0 is 1. If you put a 1 in, 2 to the first equals 2. If you put a 2 in, 2 to the second equals 4. And you'll end up with something like this. Exponential growth, there's an asymptote, and all that good stuff.